Ladies and gentlemen, a warm welcome to the another edition of 5G India 2021. Last 2 years, we have been doing this event, which is a flagship event of Bharat Exhibition on virtual. I'm sure H.L. Gupta ji will remember the fantastic event we used to do in Mumbai. The 5G has always been in Mumbai. 2019 was the last we did physically. We moved to virtual last 2 years. We had a fantastic discussion yesterday where the three operators, CTOs and CUI and the three main vendors talked about how to take the 5G to the next level. Having said that, without taking much of a time, I would like to introduce the chairman of the session. Although he doesn't need any introduction, all of you must be interacting with him day to day. But for the introduction of the new generation who comes in the telecom industry, we have around 700 plus people joined in this event. So they should know who's HL, the new generation, the new engineering students who have joined us and want to learn what is the 5G. H.L. Gupta is the President Network Service Operation in Reliance Jio. Decisive technology engineering leader with more than 30 years of rich experience, network design, deployment operations of telecommunication, 2G, 3G, 4G, data center, virtualized networks, IP, MPLS, and transport backhaul technologies, converged core platforms, and FTTH access. He is presently working as President Network and Services Operation at Reliance Jio for the last 6+ years and worked with other leading operators in the past. He's also worked in Airtel in the past before moving to Reliance. He has been leading the service experience and integrated network operations of the world's largest LTE, 4G, and all IP data network at Jio from the beginning of its operation nationwide. HL, over to you.
Thank you, Shashi, and welcome all the participants and all my panelists. So, 5G India 2021. This is a very appropriate topic as we see that the 5G trials are going on in the country by various operators at a various advanced stage, and I'm sure everyone is trying to create new use cases for the business and the sectors horizontally across multiple areas. 5G is going to be a game changer in the marketplace, and we have very eminent speakers today. Mr. John Baker, Mr. Manish Tiwari, Dr. Rakesh Mishra, and Mr. Girish Baliga. These four panelists are going to present their perspective on the 5G, whether it is from the roadmap, product, challenges, deployment, infrastructure, and the security aspects of it, and what 5G brings on the table for the users, for the organizations, and for the service providers. So today's topic is open RAN infrastructure for 5G, and if I just talk about it in terms of what it is actually the ORAN. So ORAN is going to play a very vital role in the 5G deployments. It's a cloud native radio access network with microservices and containerization designed to provide openness and intelligence. It decouples software with hardware, and that is very popularly known as disaggregation. What disaggregation means, there is no vendor lock-in. You can have multiple vendors, equipments, and software in the same access network, whether RRU is provided by somebody else, DU is provided by somebody else, CU is provided by somebody else, and the software and hardware are totally unlocked, and flexibility is provided to the operators to bring cost efficiency and competition amongst vendors while being a very intelligent network. Now, you all must have heard the cloud. So the ORAN is truly a cloud native, I would say, network element where VCUs are deployed as the edge cloud, and VRU and VDU are deployed at the far edge cloud. So edge cloud and far edge cloud are becoming a reality while we talk about the O-RAN. So far in the legacy networks or even in 3G and 4G networks, we could never deploy cloud in the access network. This is the first time, starting with 5G and massive MIMO and all the new features of 5G. This is going to be a cloud native rollout. There is another element which has been introduced in the O-RAN. We always heard about front haul and back haul, and there is going to be a mid haul now. So mid haul is going to be a connectivity layer between ODU and OCU. So all sort of technology enhancements which can bring flexibility and intelligence and power in the hands of telecom service providers is available in the O-RAN, right? So this is going to be a very critical network component or network element or network layer for the 5G deployment going forward. Now, without taking much of time, and I know you all are waiting to hear from our expert panelists, so we will go first with Mr. John Baker, who is Senior VP Business Development at Mavenir, and John Baker is Senior Vice President of Mavenir, veteran of the mobile industry, board member for 5G Americas, and sought after industry speaker. John Baker leads the 5G team at Mavenir, intent on disrupting the market by transforming operator network economies. A visionary and driving force behind Mavenir's business strategy, John is at the forefront of the company's drive to change operator views on wireless infrastructure deployment, promoting a software-focused approach to innovation with no ties to supporting legacy hardware. So welcome, John, and over to you. And we want to start the session with you.
Thank you, HR Gupta. Great introduction, and pleasure to be with you this morning. And just also, I actually sit on the board of the Open RAN Policy Coalition as well. So, really driving policy on a global basis. So hopefully I'll cover some of those points in my presentation today. So I'll just switch over to my presentation. So hopefully you can see that now. So I'm going to talk, around some of the aspects of Open RAN and get into some of the architectural implications of building Open RAN networks on a cloud-based platform. So really, as Mr. Gupta says, the whole future of mobile networks going forward for 5G really is about building networks with cloud native software and virtualizing those networks as we transition to 5G. Mavenir has been in the forefront of virtualization now for probably 10 plus years, which really started with the transition of physical GSM 3G switches into soft switches, and then into virtualized IMS core, and really now taking that virtualization experience into containerization in the RAN network. So we're all about sort of embracing disruptive and innovative technology and new business models that will really come out of virtualized technology and how to build networks with cloud native and web scale technologies. And the significance of moving to web scale really allows operators to essentially independently compete at a service level. And I think this is an area that will get a lot of focus in the future as web scale platforms are being deployed, because it becomes a lot easier to build applications and features and functionality that are coming off of an operator roadmap rather than a technology vendor roadmap. So, we're not only disaggregating the technology, we're disaggregating the suppliers and the way networks are built today. So, we've been driving, virtualized evolution to web scale, for web scale economics, and really sort of driving down the cost of building networks and operating networks. And, really this comes then to, how you integrate analytics and zero touch type software applications around these networks as we go forward. So if you look at this, pictorially, and from the block diagram down the bottom here, really everything is layered onto general off-the-shelf compute hardware. So you end up with a web scale platform, and all the network elements now, apart from the physical radio itself, are in virtualized or containerized form to build these networks, as discussed, in terms of private, hybrid, and public cloud for deployment of these types of services. And clearly the core has evolved over time in terms of open interfaces, and there's been true competition in IMS platforms, packet core, etc., in the marketplace, because those interfaces have sort of been open. But in the RAN space, it's really been very difficult for new suppliers to compete in the RAN space because of the interface between the radio and the BBU has been a closed interface. So really work that was started back 4.5 years ago with XRAN, which moved into ORAN, the ORAN Alliance, was really about opening up the front haul interface. And through opening up that interface, I think we can fair to say that we've essentially put so much disruption into the mobile industry that, in my 30 years of being in the space, that, I've never seen so much excitement and enthusiasm from companies now willing to participate in the evolution of mobile infrastructure. But when you start to look at the software approach, as I say, it's about how do I put artificial intelligence and zero touch around these networks, and also having minimal equipment deployed out in the field at cell sites. So you start to get into edge data centers and centralized data centers, and then the transport systems that join all this lot together become very important. And it's also worth stressing that the open interface really focuses on IP infrastructure between the nodes, so you can essentially reuse a lot of the IP infrastructure that's overbuilt on these networks today in deploying Open RAN solutions. The one thing I would add to this, that from a Mavenir perspective, we're seeing that 2G, has a long tail from a legacy perspective. And when we talk about virtualized networks, we're talking about 2G, 4G, 5G, essentially all running on the same platform. 3G, we have in our roadmaps, and again, that comes really down to customer requirements for 3G to be virtualized. But in reality, all of the Gs can be virtualized and containerized on a single common platform, and really resolve some of these legacy issues. But the outcome of this type of an architecture is really driving a low total cost of ownership, and putting platforms that are ready for 5G, but very much supporting 4G today. Just a little bit about Open RAN, and I see a lot of this that through the Open RAN Policy Coalition that's sort of driving the global policy for Open RAN. I really start off with that Open RAN is not a technology. Open RAN is about a shift in how we build and design mobile networks using interoperable subcomponents from multiple vendors. There's a lot of confusion that gets generated in the marketplace by the incumbent suppliers, and every day I sort of wake up to having to address some of the noise that's in the marketplace. That the fact that you're running proprietary software on open hardware, it doesn't mean to say it's Open RAN. Open RAN only exists when you have two vendors interworking together to show that you can build the networks with these interoperable components. And so, and I think, you're seeing the fact that, the incumbents are trying to keep the market locked up with proprietary solutions. But I think the energy that's now in the ecosystem is really truly driving Open RAN from an opportunity perspective, and really showing the benefits that Open RAN brings to the market. And in that respect, and this is seen, the Open RAN ecosystem We're seeing over 60 plus companies that are participating in the Open RAN Alliance, the Open RAN Policy Coalition. And this is sort of the, from startup companies to hyperscalers. And, it's really interesting to see how these companies are sort of really focusing at a common cause of ensuring open interfaces. So, from a business perspective, you're seeing competition from Open RAN. We're seeing the cost savings coming out now, and a lot of that's now becoming public as pricing catalogs are becoming transparent. There's obviously a lot of discussion around security, but we argue that that you've got increased security because you can see what's going on, you can test what's going on, and security is a way of life, and it shouldn't be underestimated. But in all of the architectures and deployment models, clearly in security and building security into those networks is very important. But the mainstay of improving security is allowing third parties to actually test it. And last but not least, we're seeing a lot of innovation now coming from startup companies and companies that have been third-party suppliers, if you like, in the mobile equipment space. And it's a great way for generating local businesses, local employment for companies to get back into the mobile equipment supply space. This slide, and I won't spend on it too detailed, but I always put this slide up here because there is a lot of noise in the marketplace.
John, I want to interrupt you. Can you put it on the PPT mode, please? Presentation mode.
Sorry, is it? I think it is.
I think you can create the click on the swap displays on the top left.
Okay. Sorry. Yeah. My bad. Sorry. Apologies. Thanks for interrupting. Is that better?
Yeah, much better. Thank you.
Yeah, my screen's actually swapped. So, so this slide really is about some of the noise that you hear in the marketplace, and I just focus on a couple of these bullet points on here that all of these items here are sort of being addressed as negative issues around Open RAN. I've talked about security, power consumption. Yes, power consumption is a challenge for Open RAN, and it's a challenge for the conventional RAN as it stands today. The radios that are being used within Open RAN are the same radios that are being developed for closed RAN, and the only change is the interface. So, when you hear arguments about power consumption, it's a non-issue. And in reality, what is needed in the radio business is new innovation in producing very efficient or very, very power efficient radios to really, get the benefits of a green effect. And I think you'll start to see the ability of new radio suppliers to bring in competitive power consumption radios. There's been a lot of discussion around about, this brownfield versus greenfield type definitions. And back in the early days, probably 2 years ago, when some of these Open RAN systems were being built, that, some of the features for building in high capacity networks were lacking. But, the fact that with software, you can move these features along a lot faster, there's taken away this difference of brownfield and greenfield. And to put it in perspective, that today, because of the way the interfaces are being controlled, especially on the X interfaces, you don't see networks being built with two vendors, overbuilding on the same cell site, because they don't interwork with each other properly, even for the existing vendors. So, this whole brownfield, greenfield thing is really, again, market positioning. And I think finally we're getting to the point where, Open RAN solutions are being used in dense areas and, can support the capacity requirements that are necessary for these networks. And then in terms of the specifications, as I say, the Open RAN journey started with the front haul interface with XRAN, which then became ORAN. the ORAN Alliance, and that specification now I think is in like five plus revisions, and it's very mature specification with test specs, interoperability specs. But the ORAN Alliance will continue to evolve all of the specifications in the 10 plus working groups as time progresses. So a lot of activity there, a lot of news, and I say Open RAN is probably the hottest topic in telecommunications today. Certainly I welcome anybody to join me on LinkedIn, and you can keep up with the day-to-day activities that we're involved in. Now I've changed my screen over. Okay, so I want to talk a bit about some of the infrastructure implications, and I think the subject of this panel, and really sort of address it from some of the deployment scenarios that you can run into when you start to look at Open RAN. And this was a case study we did for an operator looking at a very dense urban environment, comparing centralized DUs in the first line of this chart against DUs contained at the cell site. And the one thing I would say right up front is that Open RAN benefits really start to be obtained when you start to centralize. The more centralization you have from a software compute perspective is really where you get the cost saving benefits. This study, we looked at 200 cell sites, 10 edge sites, and some regional data centers, and looking at the cost and performance differences of running multiple frequency bands, massive MIMO, etc., on that type of an architecture. But fundamentally, you can see from the top chart that by moving my DUs away from the cell site, I can start to get the benefits of what we call DU pooling, and that's the ability to share one compute across several cell sites, and that really is the key to the real total cost of ownership savings in mobile networks. And typically most cell sites today have some form of fiber connectivity, it's IP connectivity. But I think the concept of building an Open RAN network is very different to building one with proprietary hardware that's sitting at the cell site. If you look at the proprietary solutions, these networks have been built for 100% capacity, to the extent that every cell site has got full capacity. It's being used, it's only being used in a lot of networks for the busy hour. And then, which is probably 20% of the time, 80% of the traffic is actually sitting on 20% of the networks. And so if you take that argument and say, look, if I can pool DUs that can work across multiple cell sites and even CUs in that respect, then I can start to, as the traffic moves through the network, I can drive capacity to suit the needs at those cell sites. And that's one of the real benefits that comes out of having virtualization in your network. Now, there's another element that is in the process of being standardized in the ORAN Alliance is what they call the radio controller, the RIC. And by adding RIC functionality to these edge units, that allows me dynamic spectrum sharing and spectrum management and capacity management. You can see you can get applications that can sit on top of the CUDUs that will drive efficiency into these networks. And just to give an idea of what we were looking at, we were driving like 7 frequency bands in this case, 7 different radio types, and running like 15 carriers, 15 4G carriers per site with 6 5G carriers. So this was a real complicated analysis for a leading operator in terms of how to build an Open RAN network and what the architecture would look like. And I think a lot of operators over time are really going to be leveraging very different pieces of the spectrum, and this is going on in the US with Dish in terms of building out that network. I think there's 5 different frequency bands that are being aggregated in the dish network, for instance, on day one of the launch. So, we're not only dealing with, the individual frequencies, we're dealing with radios that are tri-band radios, MIMO radios. And so, from a software perspective, the software has got to be very, very flexible. But, what we found was that, when the engineering teams really sort of take the concept of Open RAN, they were trying to apply closed RAN rules to building Open RAN networks, which means, okay, I'm designing my sites for 100% capacity. In reality, for building Open RAN networks, you start off building a network at 0 capacity, and then you put your compute in the right places, and have the compute really address the traffic models that are coming from each of those cell sites. Now, and for a lot of engineers, that's a very different concept of building mobile networks, but it's about capacity from a cloud-based architecture being transported to where you need it, and then the appropriate software licenses and everything else shifts around the network as the traffic shifts around. So it's a very dynamic situation, but from a modeling perspective and a sizing perspective, it's very important to start to take those elements right up front. Otherwise, you end up with people turning around, well, look, Open RAN is actually more expensive than closed RAN, and in reality, what we've seen is that the capex savings coming out of an Open RAN architecture is between 20 and 40%, depending on the countries and that. But we're seeing the real benefits now being being verified by third parties in this process. So when you take this number of radios, the front haul transport, as was talked about before, is starts to become how do I support this number of radios at a cell site, and it really comes down to having a good IP switch, that has 25 gigabit ports, 10 gigabit ports, and 100 gigabit optical Ethernet essentially between the RU and the DU, and then that sharing that transport functionality over many different cell sites. Now, with these types of products that you can get in the marketplace, you can also do an Ethernet to CPRI conversion on there. So if you can get the interface to a CPRI radio, and that's always been the challenge, but these products do have the capability for doing an eCPRI to a CPRI conversion if those interfaces were available. So you're seeing these front haul switches now essentially with multiple ports, and I've seen some with like 25 ports of 10 gigabits. But and again on this slide you see 20 times 100 gigabit interfaces needed for this type of network across 200 cell sites. But the other important piece as well is to ensure that synchronization, PTP, etc., is transported through these elements, and timing is again sort of very, very important. And conscious of time here, but when you start to break down these models, then you get into as was discussed earlier, you have the front haul interface, you have the mid haul interface for cases where you're using distributed data centers, and you may have an edge data center, with a timing requirement of 100 microseconds, through the ORAN interface, that's, fairly close to a group of cell sites, and then you use the mid haul to bring it all back. But, we've had trials where we've had the mid haul on, point-to-point microwave links, existing technology, Ethernet technology, over 500 kilometers. So, you start to have a lot of different deployment options in terms of how you build these networks. But again, I think, the important message that I would like to leave is, look, when you start to look at these cloud-based infrastructures, look at the, where you have cloud capacity, and start from an assumption of zero capacity, and then put the capacity in the right places where the traffic's needed. And, again, this has the benefits of cost savings, because you're not buying licenses, you're not buying technology that sits at a cell site, consuming power and is redundant on a day-to-day basis. So in summary, the results that came out of this study, and you can see the key effect of the pooling effects that you get by centralizing the DUs. I'm using 30% less DU capacity by pooling and assuming the right pooling gains, which is attributable to a less than 15% cost in this case. But you get these pooling benefits that really start to come into the architecture. Now the great thing about this is that over time, with the RIC solutions, processor gains that are coming from different processors, this is going to continue to improve, and we've already seen it in the journey that we've had so far of Open RAN, where we've gone across two or three different types of x86 processors, where essentially in 2 generations they've doubled the capacity of processing power. So you get the true processing benefits of the x86 roadmaps, or whatever processor type you like to use. So that's the sort of summary I'd like to leave out today. We're very welcome to sit and get into more detail if needed, but really thank you for the time and interest. But certainly, Open RAN is probably the hottest subject in telecommunications today, and don't necessarily believe everything you read, because there's a lot of market dynamics going on here. But what we're doing is essentially restarting and re-energizing the industry on a country by country basis, and I think India has got a great opportunity in front of itself in terms of being a part of the next revolution, as I would say, in the mobile industry. So anyway, thank you for your time, and happy to engage with you as you have questions, etc.
Thank you, John. Wonderful session. And if I quickly summarize on 3-4 lines, the key aspects what you covered. Open RAN actually supports all G radio deployments, and the 5G is a very wide spectrum technology, covering low band to mid band to high band and ultra high band millimeter waves, and it also supports the dynamic spectrum sharing. But what I feel is that with so much of cloud native applications and network functions coming in, the automation and orchestration will be the key to success, and therefore the MANO have to be chosen very, very carefully to reap the real benefits of Open RAN and the SA core and NSA core for the 5G. As you rightly mentioned, there are more than 60 companies worldwide which are kind of participating in the O-RAN journey. And these companies are, varying from startup to the hyperscalers to the telecom service providers and the traditional OEM vendors. So that's a good news, because at least O-RAN and 5G has brought all of them together to give end user the best experience and the cost efficiency and the affordable prices. With the growth of data happening exponentially, which registered in 4G, and in 5G will see much higher usage as well as the applications getting rolled out. What I feel that as you mentioned, that operators are at various level of implementation. Somebody is still trying to scratch the head and understand whether O-RAN is the right technology to go for it, but I'm sure majority feel that O-RAN is the right technology to adopt as early as possible, because it gives the flexibility, intelligence, and power and control for managing the customer experience in a most efficient and I would say productive manner. So thanks John, once again. And I would like to invite now our next speaker, Dr. Rakesh Misra, who is Director of R&D in VMware's Telco and Distributed Edge Business Unit. Prior to joining VMware, he co-founded Ohana Incorporation in 2015 and 16. They commercialized a radio access network intelligent controller for traditional RANs. Ohana was acquired by VMware in 2019. Now at VMware, he is driving the development of commercial RAN intelligent controller RIC solution for Open RANs and creation of a thriving multi-vendor ecosystem of RIC applications. He has a PhD from Stanford University, and I'm sure all the participants, including all the panelists, are looking forward to listen to Dr. Rakesh Misra, who has done huge amount of work in this field, And let me tell you all the guys, RIC is the most important component of the 5G, because it brings the intelligence from a just access network to improve the customer experience and the efficiency. So welcome, Dr. Mishra.
Great. Thank you, HL, for that very kind introduction. And I think you couldn't have introduced my topic any better when you said that the RIC is the most central element to the success of Open RAN. And what I am planning to speak in my session today is actually more about the RAN intelligent controller, the RICs. And I'm going to explain how the RIC holds the key to unlocking the full potential of Open RAN. So before I begin, I would like to thank the organizers for giving me an opportunity and inviting me to speak to this forum. I'm really looking forward to this. Okay, so I'm not sure how many of you saw this press release from Vodafone UK a few months back, where Vodafone announced that it has trialed a technology that increased the capacity of a 5G cell site by twofold using a technology, an entity called RAN Intelligent Controller, right? So what is this RAN Intelligent Controller and how did it help Vodafone increase the capacity of a cell site? This was actually an increase in spectrum efficiency by twofold. And let me just emphasize, what this means is that the spectral efficiency was increased by 100%. Spectrum, as you know, is the most expensive asset resource of a telecom operator. Operators around the world spend billions of dollars to acquire and manage the spectrum, and several hundreds of millions of dollars more to get the most out of the spectrum. Maximize the spectral efficiency. Even a 3%, 5% increase in spectrum efficiency is considered a very big deal in this industry. And here is Vodafone announcing that it has trialed a technology that allowed it to increase the spectrum efficiency and cell capacity by 100%. So how did this happen, and what is this RIC that made this happen is going to be the focus of the rest of my talk. So I've divided this session into two halves. In the first half, I'll explain what the RAN Intelligent Controller is all about. Many people that I talk to come across tend to equate Open RAN with Open Fronthaul and Virtual RAN. And I'm actually going to explain why Open RAN is actually much more than Open Fronthaul and Virtual RAN. And like I mentioned at the beginning, why the RIC is so central to the success of Open RAN and how it takes Open RAN beyond just Open Fronthaul and Virtual RAN. In the second half, I'll talk about the product that my team at VMware is building, the VMware RAN Intelligent Controller. And I'll explain how it allows operators to modernize, optimize, and customize their radio access networks. And I'll dive a little deeper into this Vodafone UK press release that we just saw at the beginning. Okay. So let's start by understanding what the RAN Intelligent Controller is all about. So first, we need to understand the concept of open radio access networks. And let me explain how Open RAN is different than traditional RAN. When I think about traditional RAN, the mental picture, the mental model I have in mind is the radio access networking infrastructure packaged into a closed and proprietary box that comes from a single vendor. With the radio unit, the baseband unit, and the management unit all vertically integrated in this closed and proprietary box. And furthermore, even within the baseband unit, you have the data plane components of the baseband software that is very tightly integrated with the specialized hardware on which it runs, and also very tightly integrated with the control plane. The control plane is what contains the intelligence in the network. It contains the intelligence that drives the data plane. So in traditional RAN, the data plane, control plane are very tightly integrated with each other and with the hardware on which it runs, and the entire stack from the management plane to management unit to baseband unit to radio unit is all vertically integrated. And there is very little programmability available out of the box. So when once a telecom operator purchases this box, there is very little that it can change about the intelligence that has already been hard-coded, embedded within that box. right? So it makes it very difficult for operators to adjust the intelligence in the network specific to its own deployment and its own requirements. And this is the traditional RAN architecture that has been employed for over 40 years that commercial radio access networks have been in existence. But now this architecture is undergoing a massive transformation. I would say a once in a lifetime transformation, where this traditional RAN architecture is being fundamentally re-architected. And there are two big transformations that are happening. The first big transformation is the introduction of network function virtualization to radio access network. Network function virtualization is about virtualizing your software so that they run agnostic to the underlying hardware. And then you take it one step beyond. Once you virtualize, you also then move to the cloud. So you not just virtualize the software, but then you move it to the cloud, make it cloud native. So the first step towards virtualization is to disaggregate the radio unit, because the radio unit is a very special piece, very special hardware-defined piece, very hard to virtualize. So the first step to virtualizing and making the RAN cloud native is to disaggregate the radio unit. That's where the open fronthaul came in. The open fronthaul was a standard interface between the radio unit and the baseband unit that allowed the radio units to come from potentially different vendors than the vendors providing the rest of the baseband unit. And once you have disaggregated the radio unit, the rest of the baseband unit can be now virtualized and can be made cloud native and can be moved to the cloud, can be made to run on a cloud platform on industry standard hardware, no longer special hardware, right? So the virtual RAN, this is known as virtual RAN when you bring NFV to radio access networks, is the beginning of a multi-vendor RAN. Now, instead of a single vendor, operators can now rely on multiple vendors. The radio unit could come from a different vendor. The hardware, the servers for the baseband unit could come from a different vendor. The cloud platform could come from a different vendor, and the rest of the RAN software could come from a different vendor. But virtual RAN is still not programmable. Virtual RAN is still single vendor. If you look at this software, the baseband unit and management unit, the management unit is not interoperable with the baseband unit. You cannot take a management unit from one vendor and make it work with a baseband unit from another vendor. You can't take a control plane from one vendor and make it work with the data plane of another vendor. So the RAN software, even though it has been virtualized and made cloud native, is still single vendor in nature. And this is where the next big transformation is changing this architecture. The second big transformation that is happening in the traditional RAN architecture is the introduction of software-defined networking. Software-defined networking is about decoupling the intelligence of the network from the data plane of the network, or in more technical terms, decoupling the control and management planes of the network from the data plane. So in a software-defined radio access networks, the data plane, the RAN data plane, exposes programmable interfaces towards the control plane and towards the management plane. And furthermore, the control plane and management plane themselves are architected as a platform that provides APIs for third parties to build various features and functions as applications. So in a software-defined RAN, you have the notion of a control plane platform that integrates with the RAN data plane on one side and provides APIs for third parties on the other side. And third parties can now come and build various control plane functions as apps that run on this control plane platform. And similarly, there is a management plane platform that integrates with the RAN data plane on one side and then provides APIs for developers. So third parties can come and build various management plane functions and features as applications that run on this management plane platform. So software-defined networking is what makes radio access networks truly multi-vendor, because now each of these control plane applications and management plane applications could come from a potentially different vendor. So from one vendor in traditional RAN to maybe 3, 4, 5 vendors in virtual RAN, you now go to tens or even up to 100 vendors in a truly open RAN, which has software-defined networking. And software-defined RANs are programmable because now you have third-party applications that can program the RAN, that can change or insert new intelligence, new capabilities into the radio access network. So where does the RIC come in here? The RIC is basically the ORAN Alliance defined kind of architectural element for this control plane platform and the management plane platform. So what you are looking at on this slide is the reference architecture published by the ORAN Alliance, which is an industry consortium, operator-led, trying to standardize the architecture and interfaces for Open RAN. What ORAN Alliance has done with this reference architecture is it has taken the traditional closed and proprietary RAN and disaggregated it into these different modular components and defined the interfaces, the open interfaces between any two modular components. So starting from the bottom right here, there is the open front haul interface, which allows the radio unit to be disaggregated from the rest of the business, the baseband unit. ORAN Alliance has defined this OCloud, which is that cloudification and virtualization layer we talked about, which abstracts the underlying hardware and allows the baseband software, the CUCP, CUUP, and DU to run in a virtual or containerized form factor. And then ORAN Alliance has defined what is known as a near real-time RAN intelligent controller. This is the control plane platform that we were looking at in the conceptual picture on the previous slide. What the near real-time controller does is it integrates with the RAN baseband software via this new interface called the E2 interface. E2 interface is the new programmable interface that the baseband elements, the CUCP, CUUP, and DU expose towards the RIC. And then the RIC in turn exposes APIs for these third-party applications called XApps. XApps is the ORAN Alliance term for the apps that run on a near real-time RIC platform. These are the RAN control plane applications. Similarly, as part of the management unit, which ORAN Alliance calls the service management and orchestration, or SMO, there is a non-real-time RIC. And this non-real-time RIC is the RAN management plane platform that we looked at in the conceptual picture on the previous slide. And what the non-real-time RIC does is it interfaces with this O1 interface with respect to the RAN baseband software, and also with this A1 interface, which is another new interface with respect to the near real-time RIC. And it is responsible for the management functions, the slower timescale functions, greater than 1 second timescale functions, the management of the RAN baseband software, as well as of the control plane, the near real-time RIC, right? So why is this important? Why is the near real-time RIC important for an operator? Why is the non-real-time RIC important for the operator? There are 4 key reasons. The first big reason is that it improves flexibility. It improves vendor choice, right? So like we were just discussing, now instead of relying on the single RAN baseband vendor to provide all the intelligence that is needed for operating and optimizing the radio access network, now an operator can tap into a much larger ecosystem to build these various XApps and RApps, to build these various intelligent functions for its radio access networks. Flexibility is one key benefit. The second big advantage is customizability. So when an operator today procures RAN software from a legacy vendor, the legacy vendor sells them a one-size-fits-all solution. It's the same solution that an operator in India would get and an operator in Europe would get. But now with the RAN intelligent controller, it becomes way more easy to customize the network, for the operator to customize its network based, for its own specific deployment scenarios, for its own specific business needs or business preferences, because it can now program the intelligence that was earlier embedded, hard-coded within the infrastructure via this RAN intelligent controller. The next big advantage is agility. So now it becomes very easy to introduce these new capabilities or enhanced capabilities in the radio access network in a very agile manner via the the RAN intelligent controller. Earlier, if you had to introduce a new piece of intelligence, you basically had to rely on your RAN vendor to provide a new upgrade of the software, right? But now new capabilities can be introduced in the network in a very agile manner without touching the underlying RAN baseband software. So you can introduce a new XApp or a new RApp, which gives you a new capability without having to change or upgrade your CUCP or CUUP or DU. So agility improves several folds. And the fourth, last but not the least advantage is performance. by opening up the intelligence to a much larger ecosystem, by cloudifying this intelligence, extracting it out of the CU and DU and moving it to a central location where the RIC runs, and by using advances in AI and ML, and by using advanced compute capabilities and GPUs and enhanced libraries of x86, you can now perform a lot of the functions in a much more optimal manner. So you get a significant increase in performance, increase in your spectrum efficiency, like you saw in the Vodafone trial, or improvement in subscriber KPI, subscriber experience. So flexibility, customizability, agility, performance, all of them improve significantly by the introduction of the RIC. And that is why the RIC is a very central component in the Open RAN architecture and is key to the success of Open RAN. So with that understanding, I'll now move to the specific product that we are building at VMware, the VMware RAN Intelligent Controller, which is a production-ready implementation of the near real-time RAN Intelligent Controller and the non-real-time RAN Intelligent Controller defined by O-RAN Alliance. So VMware is building two products. The centralized RIC is the VMware product name for the non-real-time RIC, and the distributed RIC is the VMware product name for the near real-time RIC. And VMware is building the centralized RIC and distributed RIC to support its any app, any RAN, any cloud vision. So let me explain this vision, this product vision and strategy of VMware with respect to its RIC. The any app vision means that we are building the centralized and distributed RICs to support any use case that operators want to introduce in their networks by any vendor that operators want to introduce in their networks. So be it an automation use case like a PCI conflict resolution or a mobility load balancing, use cases that are focused on lowering the time to resolution of common network or subscriber problems or lowering the OpEx, or be it optimization applications like energy savings, like traffic steering, like MU-MIMO optimization. So these are applications that are focused at improving subscriber experience and spectrum efficiency, or be it monetization application. This is a new category of applications that are made possible by the open and programmable interfaces that RANs expose now. It is now possible to build entirely new capabilities, new services that can become new revenue streams for operators. So capabilities like geolocation, which is the ability to infer the 3D location of a device based on its channel measurements. So in deployments where GPS doesn't work well, like indoor locations and basements, or even in dense urban locations where GPS is not reliable, and if there are location-based services that need to know the location of the devices, it is now possible to offer location via the radio access network itself. You could have a geolocation XApp that is inferring the location of the devices of interest based on their wireless channel measurements. And by introducing a geolocation XApp, the operator can now expose a location API to any external location-based service that would be interested in paying for this service to get access to reliable location. So this is an example of a new capability that the operator can introduce in its network via the RIC. RAN slicing SLA assurance is another capability, the ability to create virtual slices and sell it to enterprises or to premium subscribers who are willing to pay to get a dedicated slice of the network. It's another example of an application that can help operators create a new revenue stream. So any use case and all use cases that operators want to introduce in the network, we are building the RIC platforms to be able to support that. And by any vendor, like I said, the goal is to open up RAN innovation to the larger industry ecosystem. So what we are also offering is an SDK, a software developer kit that any third party can download and use to get jump-started with the app development process. The SDK makes it really easy to develop R apps and X apps for a radio access network, right? So this could be the same RAN vendor who may be building some R apps and X apps. This could be a third party, like a startup, another company, could be research organizations. In fact, we are working with an operator in India who is partnering with academic institutions in India, and the grad students and professors are doing research on how to build some of these innovative R apps and X apps. The operators themselves have R&D teams, data science teams who can build some of these R apps and X apps. So operators themselves can build these new capabilities very easily using the software development kit for their own networks. And VMware also is building a few RApps and XApps. So that is the any app strategy, any use case, any vendor. The any RAN strategy means that the distributed and centralized rigs should be able to support any RAN. It could be Open RAN, which supports the ORAN alliance defined interfaces like E2 and O1, or it could be legacy RAN. The centralized rig, the non-real-time rig specifically, can be introduced even in legacy RAN where the ORAN interfaces don't exist. But in legacy RAN, there are vendor-specific interfaces and SON kind of interfaces that can be used to introduce a lot of these RApps. So we are building our rigs in a way that can be introduced in any RAN, and these are truly RAN vendor agnostic and multi-vendor in nature. So it gives maximum flexibility to operators to choose any RAN vendor for the network that works best for them, or any mix of RAN vendors, and they can be assured that the rig platform will work across the mix of RAN vendors. This can support 4G or 5G. So we are building a vendor neutral platform. And then the any cloud part of the strategy means that the rig platform and the XApps and RApps can be run on any cloud platform that the operator has chosen for its network. So different operators have different strategies when it comes to the cloud. So we are building the rig platform and the XApps and RApps in a truly cloud native manner, Kubernetes native manner. So you could run them on a Kubernetes cluster of a hyperscaler like an AWS EKS platform. You could run it on VMware's distribution of Kubernetes, which is TKG, Tanzu Kubernetes Grid. Could even run it on Kubernetes on bare metal. So depending on what the cloud strategy is for the operator, could run the rig on any cloud. So that's the any app, any RAN, any cloud vision that we are building towards. So let me now come to the case study, and I'll conclude with this case study. So in this particular trial that I mentioned at the beginning, what Vodafone actually trialed was the VMware distributed rig, the near real-time rig. And we had a partner, a startup in Silicon Valley called Cohere, which built an XApp for MU-MIMO optimization, right? And what this XApp does is basically MU-MIMO, as some of you may know, stands for multi-user MIMO. It's a technology that allows you to transmit to multiple users simultaneously over the same time and frequency resource. Typically, since the wireless medium is a broadcast medium, if you want to transmit to multiple users, you have to divide them either in time or frequency. You have to multiplex them in time or frequency. But with multi-user MIMO, you can actually transmit to multiple users on the same time and same frequency slot. So it's a technology to boost the spectral efficiency and therefore the cell capacity. And this MU-MIMO as a data plane feature has been standardized for a long time by 3GPP, but it's very hard to make it work in practice because it requires a very high degree of intelligence. Without a high degree of intelligence, using MU-MIMO actually turns out to be worse than not using MU-MIMO. And specifically, the intelligence is required in choosing which users you pair together for transmitting to simultaneously. This is called the user pairing problem. And once you have paired those users, how do you pre-code the transmissions so that each user can decode its transmissions without seeing interference from the other users? This is the user pre-coding problem. So you need to be very smart about user pairing and user pre-coding for MU-MIMO to actually work well in practice. And it's such a difficult problem that even the tier 1 RAN vendors today rarely use MU-MIMO in practice. So even though the technology has been standardized by 3GPP, it's rarely used in practice. And this is where comes Cohere. Cohere is a startup that has done a lot of research and innovation in how to make MU-MIMO work in practice. And what Vodafone did here as part of this trial is introduce the Cohere MU-MIMO innovation as an XApp via the rig platform into its network, right? So instead, without the rig platform, it would have been very hard for a startup like Cohere to commercialize such a technology and bring it to a live network, because Cohere would have to work with each of the major RAN vendors to integrate this technology natively with their RAN software. But now it is possible for the Cohere innovation, Cohere technology to be introduced via the rig. And that is exactly what Vodafone did. And the result was a 2-fold increase in spectrum efficiency and cell capacity. So this is just one small success story of what the rig can enable. This is just the beginning. Like I said, there are tens of applications that different vendors, different companies around the world are working on that we are looking to onboard by the RIC platform. And this is why I said at the beginning, the RIC is going to be a very key piece in the success of OpenRAN. So that's all I had to say. Back to you, HR.
Thank you, Rakesh, and very useful and very insightful session, and very nice to know about so much of work being done by VMware in ORAN ecosystem creation, right? The most scarce resource is the spectrum. You take any G or any wireless technology, and when anybody promises a spectral efficiency improvement and RAN capacity increased by 2x, it's a wow and most welcome kind of scenario for any operator in the world. What I picked up from your session, and which I'm sure attendees might have noticed, the programmability is the key as far as the ORAN is concerned, and APIs are going to play a very, very vital role for management. And we all know that 5G is nothing but all about use cases, and imagination can go to the sky, and we can keep creating new and new use cases for various industries and horizontal sectors. Network architecture customization with RIC, I think, will be going to be a great enabler for the telecom service providers, and especially for a country like India with huge population and heavy data usage per capita and overall volume. Keeping pace with the network capacity is always a challenge, but doable with right technology, optimization and systems and automation and orchestration in place. So, great session, and thank you so much. Now let's move to the next speaker, Mr. Manish Tiwari, who is Senior VP and CISO at Bharti Airtel. He has more than 30 years of experience in information security and information operations. He is a result-driven cybersecurity professional responsible for various IT security initiatives in the Indian Navy. Prior to joining Bharti Airtel, he was working as Chief Information Security Advisor at Microsoft India. He has been a visiting faculty at Naval War College, Army War College, and various naval institutions as a domain expert on subjects pertaining to cybersecurity. So welcome, Mr. Manish, and I'm sure our participants are looking forward to look at the security aspect of 5G, which is going to be a very, very complex and very important and crucial factor in the success of the 5G.
Thank you, Mr. Gupta. And thank you for having me and giving me this opportunity. As CISO of Bharti Airtel, I actually straddled two worlds. One is the core world of engineering, information technology and engineering, and the second one is the world of telecom. And what is happening progressively, and this is not a phenomena today, but this is a phenomena which has started almost 10 or 11 years ago, what we refer to as convergence. And more of the world is now converging towards information technology. And we know that the new 5G architecture is going to be virtualized, going to be running on cloud platforms, and primarily the delineation that existed today to a certain extent went away to a large extent with 4G. But whatever little that there existed, a gap between the world of IT and telecom actually vanishes literally with 5G. So what I want to share with the viewers is that, look, all the vulnerabilities that or risks that are associated with the world of IT actually by and large get transcribed or superimposed into this new environment. And there are some challenges, and let me share a few of them. Typically, when you talk about cybersecurity solutions, cybersecurity strategies, they have largely been focused at keeping pure IT or information systems, safe. And this is where the world also grappled, particularly with a rapid adoption of 4G. That look, you largely had to leverage cybersecurity technology, which was more tuned to use cases in the IT world for the telecom world. And a perfect example of that is setting up a security operations center. So when you set up a security operations center, the core of that lies a basic tool called the SIEM, the Security Incident and Event Management Tool. Now, whilst the use cases, now these are tools which are largely based on use cases, and increasingly they are also leveraging AI and ML to detect anomalies, but they are still largely use case driven. And whilst the use cases in the world of IT or information systems are very clear, it can't be said so in the case of the world of telecom. So as we speak, there is a lot of work which is going on to say that, look, how do we come up with, how do we adapt these technologies so that they can work more proactively and more effectively in this new converged environment where you have IT, which is driving telecommunications of the future. So that is one challenge, in the field of proactively deploying solutions, in this new changing environment. The other thing, the previous speaker spoke about APIs, use of APIs. So primarily, that's a very, very important part, and that's not the only thing. So you have to understand that with the new, 5G architecture, which is, going to be cloudified completely, you have to look at security in a very, very different, with a very different mindset, and all the best practices in the field of information systems really need to come in. Now, typically the challenge in the field of IT always has been, and I'll give a very simple example. And I'll give a simple example which is very relevant to the 5G space, because it is a very specialized environment. The world has always been facing a challenge with the deployment of SCADA systems. And why? Because if you see, in many cases, SCADA OEMs who are responsible for developing the technology on open source or commercially available platforms are typically at, I would say, at a level -1, which means they are always one step behind probably the platform which is available and which is probably more secure. And this presents a lot of challenges. The other challenge that normally comes is at times the lack of synergy between the application OEMs and the platforms on which these applications typically run. And hence a very critical part of keeping ourselves not only productive but very safe is the patch management that has to be routinely done on information systems from time to time. And let me share with you that I don't think there is anybody or very few organizations in this world, whether it be on the government or on the corporate sector, who would actually be able to say with conviction that, look, we are able to deploy all our patches, security patches included, within 24 hours of these, being made available. These are practical challenges. You have a security fix coming, it has to be tested, it has to be tried before it actually goes in. Please understand that till such time a security fix doesn't go in, you're basically running on a vulnerable system. And this is a challenge, and this is a problem which is only growing. And there is no easy solution to it. So the entire 5G, the entire 5G infrastructure and its adoption has to, in my opinion, have a very, very robust governance mechanism, has to have a very, very robust supply chain, has to have a very, very robust change management process. And in my opinion, the next thing I would like to point is use of very, very strong encryption standards. And last but definitely not the least, very seriously look at deploying a zero trust architecture, because it will never be a perfect situation. So please understand that when we are talking about this whole the 5G framework, what we are seeing is that the surface area of cyber attack will only grow. And one very important aspect of risk management would be, how do you harden the systems? How do you reduce that surface area of attack by using various various processes, procedures, and technology? And I'm afraid there is no single straightforward silver bullet kind of an answer. And hence any deployment of 5G architecture must be based on a very, very strong foundation of a built-in approach to security as against a bolt-on approach. And unless we basically do that, the industry would face a lot of challenges. On top of that, you have the normal problems, which basically impact cybersecurity and risk management in an organization. And some of them, let me tell you, are very simple, but have very serious implications, and which is basically access. You have to have a very, very strong identity and access management mechanism, a very, very strong privileged identity access management, because most of the current generation cyber attacks are, and I'm talking about APT level or zero-day based attacks, leverage the weakest link in the chain, and which is the human and the endpoint, or the lack of endpoint security. So can you imagine administrator of a 5G core, his system getting compromised is like almost that you're giving a backdoor entry into an ecosystem. So there are technologies which basically allow you to mitigate such risks. They're not perfect, but it's extremely important that access control for various reasons be very, very strong. And let me tell you, in 90% of the organizations, the first thing that you find broken is the identity and access mechanism. So including privileged identity with and in many cases, you don't even have something as simple as a multi-factor authentication, although this whole concept of multi-factor authentication itself is undergoing a paradigm shift. So my only submission is that this entire thing has to be very well thought through. I think it's very exciting times. We have an amazing opportunity in India. There's a lot of wonderful work which is actually happening on all these fronts, including the risks that I have mentioned about. And I'm very confident that when India actually embraces 5G, all these issues should largely be addressed. Thank you.
Thank you, Mr. Manish. Very, very cautious, and enlightening approach to network security. And let me just, kind of add on to what you said, so that all viewers are very, very, I would say, cognizant of the fact that network security is important from day one, is not an afterthought. And IT and network convergence with the extensive use of AI and ML to manage complex systems, security becomes a very, very critical component of the whole value chain. Cloud does not actually differentiate between IT or telco workloads as far as the infrastructure management or the operations, security operations is concerned. We all know, we heard a lot about DevOps, but now the new term is DevSecOps, where security becomes a integral part of the entire development framework as the operations framework in between, and cannot be compromised at any condition. In the big data world, with the huge amount of data volumes being handled in the data lakes, security is of paramount importance. 5G security, I must say, that has been taken into consideration in the design itself by 3GPP. But what operators and vendors and the ecosystem partners, not just the network, but device and application ecosystem partners, need to make sure that these are implemented flawlessly. So thank you again for the insightful session, and creating kind of awareness amongst all users and the service providers plus ecosystem partners to take care of the security aspects. Now, let us move to the last speaker of today's session, Mr. Hrs Baliga, who is marketing manager at Keysight Technologies. He is leading marketing efforts in 5G and wireless, data center infrastructure, high-speed digital and aerospace defense business segments. Hrs has more than 2 decades of work experience in various functions, spanning from research and development, applications engineering, both in factory applications and field applications, business development and marketing. Prior to Keysight Technologies, Hrs worked at Texas Instruments, Xilinx, Corel, National Semiconductor Corporation, and BPL Limited. Over to you, Hrs.
Thank you, sir. Is my screen visible?
Yes.
All right. Good morning, everyone. How are you all doing? On behalf of Keysight Technologies, I would thank the organizers for providing us an opportunity to present in this particular session. Today, I will be presenting on Open RAN, the path forward and the test perspective for the next 15 minutes or so. So let's get started. So Open RAN, which is popularly known as ORAN, is based on the radio access networks and represents the mobile communication industry's move towards an open, virtualized, and disaggregated architecture. ORAN revolutionizes how mobile network operators, or MNOs in short, can build their radio access networks or RANs using a multi-vendor, interoperable, and autonomous supply ecosystem. As the previous speakers mentioned, RAN deployment for 4G LTE or earlier generations of cellular technologies relied largely on a single vendor model. However, these networks used proprietary hardware and software systems not compatible with the other vendors' products, thus creating a closed and an uncompetitive environment. So what ORAN or Open RAN does is it breaks down the traditional hardware-centric RAN into building blocks. Whether you're talking about radios or hardware or virtualized functions, using open and standardized interfaces. So network vendors can now focus on specific building blocks rather than building an entire RAN. So thus, operators can gain the ability to mix and match components from multiple vendors. And in this new model, the designer will perform testing to ensure multi-vendor components, they work together seamlessly without compromising on the performance. So moving forward, let's now talk about what's happening with respect to the ORAN Alliance and so on and so forth. So specifically talking about the ORAN Alliance. The ORAN Alliance, as you know, is a worldwide community with its members who are developing a unified roadmap for future ORAN standards and specifications, and also a reference architecture and the interfaces between the various components of the network. So the typical benefits can be compartmentalized into 4. It helps transformation, innovation, agility, and also like the other speakers mentioned, specifically talking about the capital expenditure savings. So when we talk about the transformation, it typically what it does is it enables more open, virtualized, and fully interoperable radio access networks. And with respect to the innovation piece, it helps choose the latest and best 5G RAN components with access to a wide variety of product, service, and feature options across vendors. And it also helps for a future, by adopting an architecture that is kind of scalable up the line all the way to 6G, which it's kind of spoken of these days. And also there is backward legacy support with respect to 4G, LTE advanced, and so on and so forth. Then moving forward, when we specifically talk about the agility, it helps gain flexibility to mix and match various RAN components for more than one vendor to construct a 5G network that works best for the designer. And also it helps deploy and upgrade the 5G network at a faster pace. And since the name itself specifies it is ORAN or Open RAN, right? So it helps facilitate the ecosystem to develop with solutions from multiple specialized vendors. And obviously, with the open kind of a network, it would help in capital expenditure savings, which is primarily helping in reduction of the 5G deployment, network deployment cost with a competitive ecosystem. So specifically, when we are talking about what's happening in ORAN right now, as you can see from this particular slide, one of the big advantages for driving ORAN right now is on the open platform. So typically, one of the big changes you would see is that of the traditional front haul technologies such as CPRI and so on, right, may not scale very well to kind of support the increased bandwidth of 5G network. So with the migration to 5G, the network is going to specifically a densification process, and operators are pushing hard to move towards networks that are more open and towards open standards, and also to improve the network resource utilization. And like the previous speakers mentioned, they can also leverage from the virtualization technologies to create conditions to maximize the performance that both help optimize CapEx and OpEx. So in a nutshell, there are driving forces which are primarily with the network densification and virtualization technologies and so on. Whereas there are a host of expected gains in terms of space saving, costing, and so on and so forth. And then moving forward towards revenue maximization as well. So moving forward, when we specifically talk about the challenges which are evolving with the ORAN Alliance that was created a couple of years ago, what we see is that the Keysight has witnessed significant growth in the membership, spanning from the chipset vendors, device suppliers, as well as operators and NEMs and so on. And there's, I believe at last count, 130 plus members on the Alliance. And the mission of the Alliance is to develop open standards, which will typically enable multi-vendor interoperable radio networks. And specifically to address this, there are 9 working groups, each one who is focused towards a specific domain. So, and then Keysight is a contributing member and the editor to the conformance test specification of the ORAN front haul interface. So, talking more about the ORAN and the path forward. So as you can notice here, to address these particular new set of architectures, so Keysight with its 5G radio access in the core network test is enabling the end-to-end testing, starting from FR1 going all the way to FR2 and the path forward. So specifically, if you're talking about edge to core ORAN solutions or the load core and so on and so forth, all the way encompassing various blocks if you're talking about the 5G RAN or the GNB or the 5G core, Keysight has solutions which enable testing of the various blocks starting from R&D to design validation, as well as manufacturing both for hardware and software testing. And then these solutions help test most of the interfaces across the various blocks of the 5G infrastructure. For example, if the designer is looking to combine UE emulation with the core simulation to test the entire GNB, it's definitely possible. Also, this would involve emulation capabilities also to test the devices in isolation. For example, if there is a radio unit testing which is being done, then the DU emulation combined with RF and millimeter wave signal generation and measurement tools would help achieve this objective. So moving forward, during the prototyping, when the designer is looking at testing his or her device, and before even it gets into taping out the silicon and primarily going into the emulator environment, Keysight helps you provide solutions which can help that as well. So specifically anything when you're looking at end-to-end, we have a Keysight which will help you provide the solutions from layer 1 all the way to layer 7. And that would help facilitate opening new doors to exciting new applications, specifically if you're talking about various new buzzwords or things which are really taking shape in the form of, say, 5G IoT networks, or you're talking about autonomous driving, or if you're talking about FWA or faster video viewing and so on. So Keysight's 5G solutions and specifically 5G RAN solutions in the form of various types of applications will help end-to-end layer 1 to 7 test, including precision measurement, deep network visibility solutions to primarily de-risk the overall 5G development and operation across the ecosystem. So now shifting gears and talking more about Keysight's ORAN solution. So we call it the Keysight Open RAN Studio solution, which primarily covers the complete audio emulation. It's an audio emulation platform for the ORU testing. So what it primarily does is it constructs, plays, and captures and measures the ORAN traffic over 10 Gbps to 25 Gbps front-haul Ethernet interfaces. And it also supports out-of-the-box integration with Keysight's pathwave signal generation for 5G NR and the 89600 VSA software, which enables sophisticated signal generation and easy capture, as you can see. So if you are specifically talking about the ORAN stimulus and analysis portfolio, or you're specifically talking about conformance, everything is highly configurable and works across domains. And these solutions are also primarily tightly integrated for both RF and millimeter wave instrumentation. So in summary, with respect to the Keysight Open RAN Studio solution, it's primarily compliant with the latest specification, and it would primarily configure to maximize the test coverage and also ensure that folks would maximize their time so that they are early to market and not specifically talking about configuring the instrumentation. In a nutshell, so there are various pieces to it, specifically talking about both the signal generation as well as the signal analysis, which is tightly coupled with the various blocks or pieces, as you can see here, either through the Signal Studio for signal generation, or if you're talking about signal analysis, you could use the vector signal analyzer tool for 5G NR. And specifically, you're talking about constructing various specific ORAN compliant stimulus. You do have the Open RAN Studio Builder and the Explorer for Open RAN EC3 protocols decode. Then you encompass that and ensure that you use the player or the capture to ensure that each part of your mechanism is taken care. Having said so, in summary, what we specifically talk about is whether you're talking about FR1 radio or the FR2 radios, right? We are there, and if you have gone through our website or the industry news, Keysight is already there in 6G, and whatever preliminary work that is happening, we are pretty much in the leading front of the next generation mobile communications as well as the cellular communication industry. In a nutshell, the 5G and O-RAN revolution is unfolding simultaneously and unlocking a new world of possibilities. And mastering the O-RAN's test requirements are very, very paramount to ensure that integrated solutions which are critical for necessary testing and ensure that you get the first mover advantage in this highly competitive market. And the summary is that Keysight Technologies is there to help you in every step of the entire 5G test, and O-RAN is definitely there. Thank you for your time.
Thank you, Girish. I think the key points and the takeaways, at least for me, the multi-vendor interoperable networks, the coordination and collaboration is a must. Without that, I think we will not be able to reap the benefits of the O-RAN or the 5G core or overall as a 5G network ecosystem. The right tools and testing capability during deployment and as well as a runtime troubleshooting will be very, very key, important, and requirement for success. The 5G services would comprise of device, network, application complexities, and the network slicing adds further to the complexity for delivering the customer experience. So, good session and very, very insightful, points which you made for our viewers. So with this, I think, the presentations are over. Now we can, give 15-20 minute time if there are any questions, any clarifications required from any of the speakers or from me. So there is a chat room available. Mr. Sasi, I think participants can ask questions and, I can route it to the concerned persons to answer.
Yeah, I think the participants should be sending. Meanwhile, HL, you can ask 1 or 2 questions by the time people post the questions.
Yeah, sure. So my first question goes to John. John, we know that the acceptance of O-RAN is very widely taken forward by many operators in the globe. Where you feel that the spectral efficiency has really been enhanced and the capacities have been enhanced by what kind of solutions which operators have deployed? Is it a out of the box solution, or they have to undertake their own development in-house or engage with any third party to achieve these kind of efficiency in the O-RAN?
Yeah, I think Rajesh put it very, very, very kindly before with the demonstration that Vodafone has done. That through these startup companies like Pivotal Comware, you're going to see these spectrum performance apps start to appear, and I fully agree with the comment that the RIC is going to be probably the most important part of the Open RAN network going forward. And to the extent that there'll be lots of different apps for very many different applications, and the great thing about it being software is that these apps can be different for different operators. So capacity, some aimed at capacity, some aimed at spectral efficiency, but there's almost going to be like an app store developed, just the same way that we have an app store for the iPhone effectively, or the Samsung phones, where people can trade different ideas and different solutions to suit out different environments. So I think we're seeing I think Vodafone are doing developments, and other operators are starting to look at developing their own X app, R apps for these products. So I think it's going to be interesting to see how this market develops.
Good, thank you. So next question, if I may ask Dr. Rakesh, how you see the comparison between the 4G scheduler versus RIC in 5G? Is there any comparison in the first place? And if there is, what are the new things which RIC or RIC brings on the table for the user experience enhancement? and for the efficiency of the spectral efficiency of the network?
Yeah, great question, Achal. No, the RIC is pretty early in the industry. It's pretty nascent. All the players in the industry I know who are building the rigs still do not have any commercial solutions. It's all pre-commercial, just getting into early trials. So I think we will need probably in maybe 1 or 2 quarters time. I think the industry will have a lot more comparative studies and measurement reports. But before that happens, if I were to share kind of where I see this is going, I think the kind of use cases that will be the focus with the RIC platform will be slightly different in 4G versus 5G. I think with 4G, the focus of the RIC will be on use cases around automation. What's happening is that with the transformation to 5G, operators want to move their ops workflows from 4G to 5G over time. So they want to automate as many of the manual workflows and processes as possible, and kind of have software manage, optimize their network so that the manual workforce can be focused on building and rolling out new 5G networks and new spectrum bands and so on. So there's going to be a lot of focus on these automation kind of use cases, the typical SON kind of use cases, or even simpler use cases like, can you detect anomalies in subscriber performance automatically? Can you identify the root cause automatically? Can you can you go and fix the root cause? If it's an interference issue, if it's a coverage issue, if it's a load balancing issue, can you go and fix the root cause automatically? Those will be the kind of apps that will be the focus with the RIC in 4G. With 5G, the focus will be really around, on one hand, precise QoS. This is a term that is becoming popular, precise QoS, which is, can you tailor the QoS for every subscriber, for every traffic category, provide precise SLAs on the QoS that, let's say an IoT traffic may need versus video conferencing traffic may need versus video streaming traffic may need. So precise QoS optimization and RApps will be one category. And then another category of use cases around pushing the performance to the next level. Because 5G is all about enhancing performance in terms of throughput, latency, connection density, energy efficiency. So apps that are focused on pushing the performance across all these dimensions, throughput, latency, connection density, energy efficiency, and so on, to the next level. And then the third kind of use cases, which I briefly mentioned in my presentation, is monetization, which is innovating about new capabilities that you can deliver now that you have a 5G network. How can you 5G is very capital intensive and it's going to be very OpEx intensive. So operators want to make sure that they can get returns on their investment, right? So there will be a lot of focus on introducing new kinds of capabilities so that you can monetize, operators can monetize their 5G investments better. So those will be the kind of use cases that will be the focus with the RIC in 5G. Precise QoS, taking performance to the next level, and creating new monetization capabilities.
Wonderful. So, Shashi, is there any question from the audience?
Did you get anything directly? I think 1 or 2 direct has come to you.
I don't know, in my chat box, at least I'm not able to see any question. If Ranjit or anybody is able to
No,
see.
I think 1 or 2 must have come to directly. They're saying send it to HL.
So if I am not able to see either
No, I'll you continue. I'll send you on your WhatsApp if there is anything.
Okay. So John, another question for you, which I'm sure people can benefit from it. What do you feel? The current deployments which have happened worldwide, percentage of O-RAN versus I would say vRAN in the 5G world.
Yeah, so certainly, I think you're seeing some very early vRAN implementations now. From a Mavenir perspective, everything we've delivered is ORAN 7.2x compliant on the front haul interface. To the comment earlier that about the management plane, there's been some differing of management plane. I think we've interworked with 10 different radio vendors, and we've seen some variation in management plane to the extent that we believe in helping our partners get a common management plane there. So we have the ability to share software and license software to support a common management plane, because again, I think from an industry perspective, if you're buying radios from different vendors, from an operator perspective, you want one management plane to work off of. Otherwise, it's going to get very complicated from an O&M perspective. But some of the very early deployments are sort of very mixed in terms of virtualization to proprietary interfaces. Now, that's one of the things that we're seeing from an incumbent perspective. People are talking about Open RAN, but in reality, all they're talking about is vRAN with proprietary interfaces. So there's still some confusion in the marketplace, and it does come back to the statement I made right at the beginning that unless you're demonstrating open interoperability with a 7.2 interface, for instance, then you really don't have Open RAN. It is a proprietary vRAN type solution. So we're constantly trying to keep the press, if you like, straight every day on these subjects as the confusion is still in the marketplace.
Okay, so we have a icebreaker, one question from the audience, and the question goes like this: does it require additional hardware to upgrade from LTE to 5G? So, I mean, I can answer it, but maybe any one of the panelists want to add on to top of it, most welcome. So definitely, as far as the radio network is concerned, we require G node B, and LTE requires E node B. So for G node B, depending upon the frequency band which has been allocated to the operators, you need to have the radio equipments, the RUs which you talked about, and then you can deploy the CUs and DUs combined or segregated, disaggregated. So G node B will definitely be required based upon the frequency spectrum allocated to the operator. As far as the core network is concerned, core network can have two variants, non-standalone mode and standalone mode. In non-standalone mode, you can use the 4G core to large extent with certain components on top of the EPC. And if the voice is on the VoLTE, then VoLTE fallback can happen, EPS fallback. And if VoNR is to be rolled out, which is still under very early deployment phase by several operators in the globe, so VoLTE can be supported by the existing IMS networks. If it is a standalone mode, then the entire 5G core has to be rolled out. As far as IP and backhaul network is concerned, only you need to enhance the capacity to meet the high bandwidth requirement and other things. So from the network perspective, yes, radio must change. Core, yes or no, partially. And if you want to go for SA architecture, everything has to be a fresh deployment of 5G SA core. So this would be my answer. Anyone wants to add anything? Most welcome.
The only thing I would add is that many operators are combining their upgrade to 5G with also upgrade to virtual RAN and Open RAN. So if operators are also moving to a virtual RAN architecture, then they would also need additional hardware in terms of their edge data center or far edge data center compute and other kind of hardware resources needed to run the data center. So that is a new category of hardware requirements.
Yeah, I would say what we're seeing as well is that some of the operators are starting with 4G as a virtualized Open RAN solution, and so moving from 4G to 5G in Open RAN is a little bit easier. That depending on the bandwidth, you may need an accelerator card in the CPU or in the DU, but and the radios can be upgraded from 4G to 5G with a software upgrade. So it does get a little bit easier, but again, we're just starting to see some of the operators wanting to have both 4G and 5G. There may be separate DUs there to start with because of this accelerator card issue, but it's very close to having 4G and 5G and 2G actually running on the same platform side by side in different containers.
Thank you. So if we don't have any other question, then maybe we can, kind of.
Oh, no, HL, there is one more question to Manish ji. How secure is 5G?
Okay.
I think I sort of articulated on various issues. However, let me just tell you, I talked about API security. This is entirely virtualized. So there's going to be a large number of applications and probably a multi OEM support. A multi OEM, sort of architecture. It's going to be a heterogeneous environment. So I would say application security is going to be very, very important. One thing that we have learned in the field of applications is that, when they come out, they follow their own life cycle. You can be rest assured that there will be upgrades. They will need, they will follow their own, a development life cycle through its journey, through its life. And application security and change management, believe me, is very important. Mr. Gupta actually pointed out very correctly, it is not DevOps, it is now DevSecOps. And unless it is basically addressed as DevSecOps, you're really asking for trouble. I mentioned about access control. I mentioned about ZTA. I mentioned about strong encryption standards. Let me give you another example, right? Today, you have a lot of M2M connections and many of them are not even properly authenticated. So very strong access control. I would say 5G infrastructure, it can be very, very secure if you have an inbuilt approach to security. So there is a lot of work which is happening, including a framework on which some agencies, including NIST, are working on. I think there is a lot of heavy lifting has been done. A lot of heavy lifting yet remains to be done. But I'm very, very confident that with the frameworks, the security standards, and the frameworks that we already have, we can implement a very, very secure and robust 5G infrastructure, provided we address all the best practices and implement them diligently. So that's my answer.
HLG, there is one more I've sent you on WhatsApp.
Yeah, okay. So this is the question
from Keshav.
Yeah, right. So is there any QoS or QCI change in 5G as compared to 4G? So Dr. Rakesh, you want to take it?
Yeah, sure. I can give a quick summary and anyone feel free to add. There is a difference, the most fundamental difference. By the way, QCI, what was QCI in 4G is called 5QI in 5G. And the big difference is that in 4G, the QCI was on a per bearer basis. So if you look at the protocol stack, you had the MAC, RLC, and PDCP layer. So you at the PDCP layer, you had the concept of PDCP bearers, radio bearers. The QCI was applied for every bearer. Different bearers could have different QCIs. In 5G, if you look at the NR protocol stack, there is a new layer that has been added above PDCP, which is called SDAP, right? So it's now MAC, RLC, PDCP, and SDAP. And just like you had the bearer, the concept of a bearer at PDCP layer, you have the concept of a QoS flow at the SDAP layer. So now there's a new abstraction, new concept called QoS flow. So a single bearer could be carrying multiple QoS flows. And this 5QI, which is 5G quality of service indicator, can be applied on a per flow basis, per QoS flow basis. So that's a kind of a big shift. It introduces a lot more flexibility in 5G because even within the same bearer, you could create multiple QoS flows and assign different 5QIs. So for example, if I set one bearer to your device, your handset, and within that one bearer, I could create a QoS flow for video conferencing traffic, and I could create a QoS flow for some other background file download traffic. And the network can assign different 5QIs for these two different flows, which is carried within the same bearer. In 4G, that was not possible. You had to define, you could only define a single QCI for the entire bearer, right? So that is a new addition in 5G, and that introduces a lot more flexibility in 5G. Again, going back to the earlier point I made about precise QoS, this is what makes precise QoS possible. But anything you'd like to add, HL or John or anybody else?
No, I think you already said, with great details. The
Very
4G
good discussion.
4G QCI was quite simple, I would say, architecture. It was using QCI 1, 2, 5, and 9, and it was bearer based. But 5G will be very, very complex, but very, useful from the customer experience perspective, because network slicing brings that picture, in a greater detail, where we can customize and optimize the services depending upon the new QoS framework which you just mentioned. John, you want to add anything?
No, I've got nothing. That was a very good description. I think I'm nothing more to add.
Yeah. So first of all, it's a great question, and I'm sure the audience will benefit by and large. This is a very important change which is happening from 4G to 5G.
Yeah.
Yeah.
Okay. Thank you very much, HL. Do you want to sum up, HL? Anything finally?
No, yeah, definitely. I think it has been a wonderful session, and all the speakers have given very good insights for the audience to benefit from the upcoming technology, which in India is yet to be deployed, but globally, so many operators and so many networks have already been upgraded to 5G, and it's not far. Very soon we will see 5G, and the kind of technology evolution which has happened is going to benefit multiple industries, and not just the human beings are going to be connected, but machines and machine to machine communication, low latency, ultra reliable and low latency applications are going to pave the way going forward. And the very interesting use cases are going to be seen in future, whether AR, VR, or you name the application. Autonomous driving is little far, but yes, extensive trials and extensive work is happening on those fields as well. Industry 4.0, smart grids, smart energy systems, smart metering. I mean, there are so many, agriculture, healthcare, telemedicine, education, you name the application. There is a huge list which anyone can pick up and start working on them. It brings a lot of opportunities for developers, for many software companies, apart from traditional telco vendors. The kind of ecosystem which is being participated and contributed by hundreds of software companies into this area is a very, very welcome news. So very, very appropriate topic for 2021 and going forward. So thanks a lot, Sasi, for having me and all the panelists. And it was a great session. Thanks a lot.
Thank you, HL. Thank you, HL. I like that 5G is going to be a reality, inshallah. Soon we'll have 5G in India. HL, there is one last question has come up. Is anyone working on 6G?
So I'm sure, there are 6G conferences also happening in parallel when we are talking about 5G. And there are a lot of material already available in the internet, but it's a too early stage. What I gathered is that maybe 2028 or 2030 could be a reality for 6G. So we are little far, maybe, it may come early, but the latest predictions which I heard, the 6G symposiums which are happening, they're talking about 2030, because 5G will give, first of all, 4G has given what all we required. 5G will give more, and 6G is something, as far as I know, is, very exciting and, beyond imaginations.
When should I have the 6G event, HL?
Not at least for next 3-4 years, I would
say. Okay.
Can I just add a minute, maybe 30 seconds?
Yeah, please.
Yes.
Yeah. This is primarily exciting the test instrumentation companies, primarily because, hello, am I audible?
Yeah, your video is off. Yes.
Oh, sorry. So this is enthusing the test instrumentation companies specifically, primarily because as we keep saying in seminars and conferences, right? Test and measurement companies are typically on the edge of the next technology curve, right? So with respect to 6G, there is already work which has started in the kind of a very groundwork kind of thing, which Keysight is already working upon. And some of our senior folks are already working on some of the sub-terahertz test beds for 6G research and so on with some of the research organizations. And like you folks rightly mentioned, right? So it is still in the infancy, but there is already work which is already happening as a flagship program. 6G is going to happen, but when, yeah, obviously it may take another decade or so on. So the long story short is, yes, 6G is already in the works.
So Keysight is already working on 6G.
Yeah,
So
and if you go to our website, right, there is a ton of material on 6G as well on the preliminary work.
Okay, so we have 3 minutes more before we move to the next session. So HL, there are 2 more questions. Now the questions started coming suddenly. Are there established vendors who can integrate different components of open network and provide requisite backup?
So maybe John or Rakesh can take this up.
Yeah, there's a number of system integration companies that are putting together networks. I think you've seen, the press, there's been some announcements this week with system integration companies like IBM and others are getting into the space. And, obviously, you've got the companies like HCL and, the Indian companies that are all taking part in the system integration. So again, it's, we're right at the front of, Open RAN deployments, and, Mavenir is acting as a system integrator as well for the first deployments. But over time, we see, lots of new system integration companies coming to the market.
Yeah, so just to add on what John said to the person who has asked this question and benefit of all, there are multiple vendors who have end-to-end ecosystem supporting O-RAN, supporting 5G SA core and NSA core and converged core as well. So integrated core. So there are vendors, but yes, maybe in the back end they have a tie up with multiple partners, but there are system integrators which are kind of playing that role. Yeah. So just coming to the next question, does 5G support mission critical services? Definitely. 5G has got 3 main services categories. One is EMBB, which is evolved mobile broadband, and then the next one is URLCC, which is ultra reliable low latency communication, and the last but not the last is basically this machine to machine communication, massive machine to machine communication. So definitely it supports the mission critical, and for mission critical what you need is the very high reliability, and what you need is a low latency. Say for example, robotic surgery is a mission critical, autonomous car is a mission critical, where your life is at risk in both the cases, when you are being operated or you are being driven by machine. So so many cars, so many trucks or other transport components are around you, and you are not on the steering wheel, and somebody else or a machine is actually driving you on the highway. So definitely it's I would say most mission critical and supported by 5G, will be supported by 5G. While there are other things like AI, ML and other sensors and other things play a vital role, the redundancy of all that has to work. If one fails, it doesn't mean that the brake will not be applied. So, but as a technology enabler, yes, 5G supports that, because what you require is a immediate information, low latency. So that is kind of less than 10 millisecond of kind of latency is a reality which is being achieved. So yes, it supports.
Good. So we come to the end of this session 1. Thank you, HL Gupta ji, for chairing this session. Fantastic. And thank you to all the speakers in this session. Thank you very much for joining us today. We will be moving to the next session. Thank you very much.
Thank you so much.
Thank you. Bye-bye.
Bye.
Thank you. Bye-bye.